Good afternoon, everybody. Welcome to this webinar in our sectorial series. Thank you, everybody, for joining. I'm very happy to see so many joining us this afternoon or this morning, wherever you are. Today we will learn how a well-built energy management program can, in one university, can save up to €1 million. Of course, we will have a look to all the pieces that are inside this project. We will see how monitoring is one of the pieces. The ones who are here today to help you are myself, Niklas Lagerblad. I'm the sales director at Dexma Technologies. We will listen to Didac Ferrer from the university, the Polytechnic University of Catalonia, who will tell the true story about how to save €1 million in his university. And then Daniel Uches will help us show the actual software that is used in this specific project. You will see that on your screen you have a small questions box, so please feel free to ask questions. We will take care of those afterwards during our questions and answers session. Nevertheless, you are more than welcome to write your questions during the presentation. We will answer them afterwards. First of all, I would like to dedicate a few minutes to just tell you a little bit about Dexma, who we are, what we do. Dexma is a software company. We make energy management software for corporate, commercial, public administration, industrial sectors, basically anybody who consumes large amount of energy. We provide a platform that helps identifying ways to save on energy, that we then commercialize through our partner network to a number of different segments and sectors. We work with every kind of customer, from corporate buildings to, as we will see today, universities. We work with large hotel chains, supermarkets, restaurant chains, museums, public administration, different types of industry. And also we collaborate with different utilities companies who provide the service towards their customer base. The way we are set up is we are working closely with our more than 150 partners that we have in 23 countries all over the world. Our software has been translated so far into 10 different languages, and we are continuously adding more languages as we're entering in the new markets. We have about 8.6 billion readings stored in our database. We are growing with about 7 to 8 million readings per day. We are currently handling more than 9 million square meters among all our customers. The partner network that we have set up, and we hope that we will be growing, so we cover the whole world with our software. As you can see, these are the 23 countries that I was referring to before. And if you are a potential customer, you would like to know more, let us know, and we will put you in contact with the right partner for you in the right part of the world. So what we provide from Dexma is a platform that helps you through the whole energy management value chain, from the most basic, which would be handling your energy bills and tracking the consumption through your bills, to the most advanced reporting, benchmarking, alarms, and reporting. Normally we would cover from bills through your fiscal meter that you have installed in your from your company, your electricity or gas or water company. Then we do sub-metering, where you go into the different circuits above the basic consumption to identify the sub-consumption in climate, light, any sub-consumption. And then we provide a full analytics and benchmarking platform and advanced reporting. We integrate to more than 40 hardware vendors, so we're completely hardware neutral or hardware transparent, independently on what meters you have installed. We try to take care of basically anywhere we can get data into our platform to help you have a complete monitoring of your energy consumption for all your buildings. The architecture is that we are, as you saw in the beginning, we are a completely cloud-based solution where you have your different devices that through communication gateways, any type of communication gateway you have, or if you already have some data in another database, we connect to any of these places via internet and we put it inside of our platform. That way we can gather data from very many different types of sources to help you take full advantage of the solution, creating your KPIs with data from completely different platforms. So just before finishing here my part, I would just like to encourage you to go into www.dexcel.com, register for a free demo for 15 days where you can go in and see the full capabilities of the tool in three different demo projects with real-time data that will show you an industrial, one supermarket with solar photovoltaic production, and one corporate buildings example, where you can see completely different characteristics of three different projects to give you a feel for how it would be to be using our system on your own data. With that, I would like to hand the word over to Didac Ferrer to tell us all the details on the Polytechnic University of Catalonia case.
Okay, thank you, Niklas. I don't know if I will go with all the details because it could take some days, but at least the most relevant ones. So my work at UPC is Head of Sustainable Management Office, and in the last years I've been responsible of working on the energy saving strategy. Let me show a bit how it works. Fundamentally, we base our work on people, not on technology. That can sound a bit strange, given we are a technical university, but here is where the paradox comes. To save energy, people are much more important than artifacts or technology. We are working on a very old problem. There is a typical saying in our country. It says, what is common belongs to nobody, and that's a typical problem of managing public or common resources, especially if you are in a public space, a public building. What you really are used to is that as it's for everyone, nobody takes care, and that's obviously also happening with energy. What's our university? What does it look like? It's a 40,000 students size university with around 4,000 employees, 8 campuses around Barcelona. So an important dispersion, 23 schools and faculties in 8 cities around the city above Barcelona, around 90 buildings. And we spend more than 5 million euros electricity and water together every year. So if you want in an organization to save energy, you have 2 main strategies. One is energy saving and the other is energy efficiency. Energy saving is based on cutting unnecessary consumption, while energy efficiency is using equipment and smart operations and systems to use less energy. What we think that is very relevant is to do it in the correct order. So start first by adjusting the amount of energy you need in your community, and then invest in technologies to use the minimum or require the minimum in your equipment. If you do the other side or the other way, you normally over-dimension your systems and you spend too much energy. We set a goal 3 years ago. It was in 2011, and the goal, because we had some budget difficulties, very important difficulties here in Spain, and especially in our university, and we decided, and it was decided by the board, to reduce 25% of the total consumption of energy in 4 years compared to 2010 levels. So you see here the graph on the left of the target and the goal in 4 years, and on the right you see that given that the price of the energy per kilowatt hour keeps, or we imagine, as it has been, it would keep going up, we would at least keep the total cost constant, flat. So at the end, we were managing some kind of degrowth at the university, was to come back to the levels of energy consumption of the year 2003, so around 10 years ago. This has been the trend in the last 4 years, and you see that last year we consumed 20% energy less than 3 years before. So we are getting those results there. This is both on the gas and the electricity, as you can see. Electricity here is, yes, you can see here is this. This is the evolution of the electricity, and below the electricity of the evolution of the gas. Especially gas has gone down seriously. And this is happening every month. Here you can see this is the last month until this last March, the evolution of the 3 last years months. So January, February, etc., in gas up there, and electricity down there. And you see that the trend is getting there in almost all months and during all the years. So this year we are getting this 23%, so even more than what we had last year, and we feel that we are going to reach this 25% goal. If we count how much we would pay, or we had paid last year, if the level of consumption had been the one of 2010, we would, with the prices of last year, cost of energy, what we see is we saved around a bit more than 1 million euros. So we would have been paying 1,100,000 euros more than we really paid. So this idea of flattening our cost is we are getting there. How did we got it? So in fact, our energy strategy has different components, and we can graph them or draw them here on this image. You can see we have, and I will talk later on about that, maybe this is a cornerstone of our strategy, the energy optimization projects at building level. Then we do a lot of training of people. We also have a working group of energy managers at each campus. We also do some investments on energy efficiency systems, and obviously we have this monitoring scheme and system that we are talking today about, and we also use some kind of information platform on the website that is the reference point of all our strategy for the university community. One of the key ideas concerning monitoring is that we have hosted all the energy data of the university in the last now 9 years in an open way. So anyone can access in a totally transparent manner to the energy consumption of our buildings, and at any moment and from anywhere, and that's especially relevant in the outcomes of our strategy. I'll come back on that later on. So we have also a group of people that have been trying to save energy as in the maintenance operation of buildings. And even if we are a university, so normally we say that the knowledge is in the academic community, I have to say that in the managers, so the staff guys, there's a lot of expertise in the real tactics and ways to save energy in our buildings, and that we build our strategy on that. I said before that the cornerstone is this strategy. It's this energy optimization project at building level. The goal is to increase the number of people involved in energy saving across the university, and get that anyone talks about energy savings in some moment during the year in the community. What is POE? We call it POE. It's not a plan for investment in energy efficiency. It's not the work of, or the job of the maintenance guys there. It's not a plan to improve our buildings or a grants plan. What it is about is an innovation management project at the building scale. So the community of users of one single building, as I say, we have 90. Sometimes we have grouped some, so at the end we have some around 45 projects of that type that have this level of the building. We have an economic incentive, internal economic incentive of 25%. This means that if you save 100 euros at the end of the year, the manager of the university gives back 25 to your building for new investments, normally in energy efficiency. It's about online and teamwork, creating some communities of practice of energy savers. It's about rationalizing the usage of the building, create savings culture, and take advantage of our resources, and finally change habits and routines. And so that's why I talked at the beginning that we really need and count on people, because all this needs people. It's not machines that do it. We had a voluntary approach. So 3 years ago we made a call to the university building responsible, saying who wants to play that game of having one of these projects in your building, and if you at the end the contract is that you do some kind of work to optimize the energy consumption, and at the end of the year the manager gives you back this 25%. Well, this automatically created some kind of interest from people that heard the word euros, and that normally when you talk about kilowatt hours or energy or planet and so on, maybe it's not the same type of guys. So we got 13 buildings, around 30% of the surface of all our campus playing that game. Next year, many observers saw that, well, these 13 guys got some money, and they, without so much effort, even some of them even succeed to motivate their staff and community with new projects and new transversality around staff, academic staff, management staff, etc. So we got an increasing of participants, and this year, almost all buildings from just 3 are not there, are playing that internal game. And so in fact we mainstreamed without forcing this idea of saving energy at the university. We have based all this with this cooperation world of attitudes, collaborate, co-direct, co-leadership, etc., etc. And that's fundamental to create a community of people that do it because they believe it's important, and not simply because there are others from the top, which in fact in a university, as in other organizations, doesn't work at all. Here are some of our, let's say, believers and practitioners. You can obviously this is in our language, in Catalan, but you easily can understand it, especially if you are Spanish speakers. And these are examples of people from our community telling to the others and to the rest of the world what they are doing. So we have this website where we show the progress and the work of different people. We have also helpful tips and messages and examples and so on. We have also a newsletter that anyone interested can receive every 2 or 3 months with updating the community what was being done. Obviously we have some kind of stickers that people can put around their facilities or whatever they use. And thanks to this monitoring system and the EXMA system, we got, for example, reports that you can subscribe, you can adapt to your needs, to your building, to what you need, and receive this kind of report, for example, every week or every month, depending on the level of intensity you are working on in those projects. The interesting story is that normally in an organization, this kind of reports simply goes to the 1 or 2 people, the energy manager, maybe the financial manager, and that's all. In our community, we have more than 150 people that have registered to this system. We call it Sirena, but this is our name for the DEXMA Tech. And this is our information system for energy resources. And so the idea of spreading really the use, some kind of self-service access to data is fundamental for us. We train people because using these kind of tools and understanding the energy parameters and fundamentals of energy management keywords and so on is not spontaneous. So we do some training course. We trained more than 100 people last year. We continue training people, and that's part of our work. At the end, what we want also is that when people see the building, this is the building where I work every day, people could also see another picture of a building that would look like this one. Here you have the different days of the week, and you can recognize the peaks as the day energy load, and you see the hour where we go for lunch. There's a negative peak up there, etc., etc. So that interpreting this graph nowadays is something that is being done by many people at the university, and they rapidly understand, well, we have to decrease this baseline consumption by cutting consumption during nights and weekends. We could start our consumption a bit later and maybe close a bit before, so the surface bit below this line counts for the total energy consumption, etc., etc. These are the kind of reports we get from the monitoring system. This is, for example, the comparison of the energy consumption. In green is last year monthly evolution compared to the year before, and year 12 and year 11, and you really see the progress. For example, especially in August, you can see how closed this building became in August, while in previous years there was a remaining consumption probably for very few people that used that building. This is the place where Danny and I studied some years ago. I have to say that we have a special pleasure to work with DEXMA because they are a spin-off of our university, so at the end there's an emotional link here. But anyway, that's really an old building on industrial engineering that, as you can see, is getting an improvement of the energy consumption, even if the building is an old one with very poor insulation and other systems, etc. Also, as we are proud to say that we are working with people that are not normally working with energy, like, for example, librarians. These are our libraries, and we had a pilot project last year where our librarians, with some help from us, were capable of writing the first, we think it's the first, maybe it's not, energy saving guide for libraries in the world. And it's published in Catalan and Spanish. You can download, and it's helpful for. It's written in a non-specialist language. Obviously, a librarian has not normally an engineering degree in energy or whatever. Where do we go? Well, what we want is, as other universities do here, for example, the University of British Columbia, we want obviously to become living labs, so our campus to become living labs on energy efficiency, energy sustainability. And for that, obviously we can do some prototypes, and this is an example of work done by our researchers, but the best lab is this one, is our real facilities. This is a main library of our North Campus in Barcelona. And when you play with that lab, which is a real building with the real behavior of real people, you learn real knowledge that you can apply immediately to optimize your system. So there's kind of an interactive approach to optimize our sustainability that we are applying in our campuses. And this very building, you can see how its consumption changed in the last years. There was the median between 2007 and 2009, and this is the consumption of the year 12. See how much we saved, and you can see it as a success. You can also see how bad it was managed before. But in fact, the level of use has not changed, but the level of clever management and clever use has changed a lot. Some kind of, we work especially in behavioral change, and I really recommend you to read this short article in The Guardian, because it says good truth about what works. And simply to make a summary, what works for changing behavior is not telling philosophy to people, it's giving them practical tools, it's about empowering them. You must involve and engage people, not just one day, but in a trip, in a long journey. The context affects behavior of people, and if you don't take in account the contextual situations, then you miss maybe the most relevant reasons why people behave in a manner or another. Collaboration is fundamental. When you trigger collaboration, immediately appears innovation between people, because and that's what we need, innovate, exchange, and so on. And at the end, when you want to interest people in your community, and we have this 1,000 of people there, when you talk about work, money, or family, that really matters to them. So when you help them saving energy at their working place, for example, they rapidly learn to save energy at home, or then they connect to the future generations, so their son or their daughter, or etc. And that's really, really important. Even if you save energy, and this avoid some firing out some people because the budget of the university is better, that's also relevant for work, and that's important. So let me conclude with some ideas, key ideas. One is we have achieved the objective set. Sorry. We got this involvement of the community, and especially we got it because we provide details and explain the strategy. It's not a central committee that thought everyone without the community. It was really participatory and empowering and a collaborative way of working. The monitoring system for that has been essential because it shows immediate feedback of efforts of people. Then closing our buildings in non-teaching period has been crucial, and it's not only giving direct savings, but also it shows that it's an idea of sufficiency. Sometimes opening a building just for the use of 3 or 4 people, it's not reasonable. And we, in the abundance days, we ensure that. And today's we cannot have this because it really seemed as a bad public management way. Then promoting collaboration and learning through the teams, working groups, and so on. And as we said, today we are more than 200 people involved in that strategy. 3 years or 4 years ago, we were less than 10. So that's when I talked about it was about people. It's really about people. It's not about kilowatt hours. Where do we go? I said at the end, once you have optimized your system in terms of consumption, there are two things that we want to do. One is to start producing our renewable energy, and the other is to invest in efficiency of systems, because there's some kind of limit of optimization strategies. You cannot ask people to make a diet and make it again and again, and at the end you lose them. Okay, so that's it, and our idea of the campus as a laboratory is somehow a strategic relevant idea that helps to create that transversal collaboration. I think that's it. Well, that's the idea, so we hope to change that saying in what is common belongs to everybody, not to none. And what we have to avoid is that type of decisions. Okay, thank you very much.
Well, thanks Didac a lot for being here today in our panelist in that webinar series. That's a special case study with a level of savings. It's a massive savings with more than 1 million euros, and getting your goal of 20% of energy, and at the end of the year you will be at the 25% the year, coming back to the 2003 levels. So that's really impressive. So, well, I would like to advise to the audience that you maybe have some doubts now, and it would be great if you start asking questions. And we will go now for a little demonstration. Maybe we will take less than 10 minutes, maybe just 5 minutes, in order to know how the university works with that monitoring system. And after that, we will come back to the questions, because for sure it's a very interesting case. Okay, Didac? Perfect. So let's move from PowerPoint to the real life. Let me change this. Yeah, here we are. Okay, so as Didac told you, if you go directly to www.upc.edu/Sirena, here you will see the data open for everybody. So the university, it's doing an exercise of transparency, and they are publishing all the information regarding their energy data. Of course, most of the labels are in Catalan, but then you can change that into English, right? So you can have most of the menus in English right now. Not the widgets labels, because that's hard coded. So that's the real title in Catalan. But you can have a look at the evolution, or then go into the analysis second even, and start going in deep and seeing, okay, which is the total consumption for the North Campus in the university, and it should be, I don't know where right now, but maybe you can press that one, which is the HVAC system where Didac is working, and then have a look if he was climatizing or not during yesterday, for example. Okay, so the university is doing that exercise of transparency, and that's a good part of that project, right? So they are fully open, and they also open the platform with lots of tools to anybody who wants to have access to that. So just ask to Didac to create you an user, and he will do it. Right now, what I would like to go, it's where I would like to go, it's to authenticate myself. Well, I will use the Didac user name. So I think it's that one, at upc.edu. Don't tell me the password. Okay. So maybe it's that one. Yeah, here we are. We are in the UPIS project. Okay, we have more than 200 devices here and 95 buildings. So it's a very big project for us, and it works perfect. So, for example, he has lots of information and dashboards, such as that one, where he can see instantaneously which is the peak demand in the last quarter, for example, which is the evolution hour by hour for the total energy consumption. which is the gas consumption for the last 7 days, for the last 24 hours. So there is full of information here on the average temperature, for example. Okay, so that kinds of dashboards can be set up by the user itself. Then you have the analysis part. Okay, so here we are. And here, for example, DDEC can make kind of those analysis. So you can go and select, okay, so filter. I don't want to analyze all the buildings, but only the libraries one. So you can select all the, well, you can select the TAC library that in Catalan it's biblioteca, okay, and then select all the devices and then say, okay, so give me the information so far this year in a monthly frequency, okay. So here we have all the information month by month, and then you would like to compare with the same period last year, okay? So you can have a look, quickly have a look, if you are reducing or not your energy consumption, right? So all the libraries, and I have to congratulate DDEC, are reducing in average like 20%, okay? So congratulations again. Even more, you can start applying ratios such as surface, heating degree days, cooling degree days, average external temperatures, so you can start comparing. So for example, you have that building from here, which is consuming 77 kilowatt hours per square meter, and if you compare with the previous year, okay, but you're reducing a lot in that one, so you are doing a good job here. In the other hand, you have that other one, which only consumes 11 kilowatt hours per square meter. Of course, that comparing buildings against the others, sometimes it's difficult because there are full of many things that are occurring there, right? But you can have a quick look here. I will change that, excuse me, to English. Apologize for being so rude. Okay, so now it's in English more or less. And there, for example, you were telling, yeah, you're using also, and that's a great point, the measurement and verification projects, and you're starting to use them to verify the POEs, the optimization energy projects, right? So using our measure and verification tools, DDEC can easily access to their portfolio of their investments. You know that they are getting 25% refunds from the whole cost that they are saving, right? So the year after that, with that 25% refund, they are investing again. So that groups of people inside any building are investing again in, I don't know, changing maybe some lights for LEDs or trying to install a presence detector, something like that. So after that, as they have data in real time, they can start verifying their savings using that tool as well. And if we go to the reports, just for end, because I don't want to speak a lot on that, they are using that kind of reports for more than 100 people. So, for example, if you are registered as a user and DDEC is creating your report, or you can create your report yourself, okay, so you can have a look and month by month have the tracking about in your particular building, how are you performing against last 3 years, right? So that's what we created especially for the UPC project, and it's very helpful for the people who is working day after day in the POEs. Okay, guys, so I think that's more or less my demonstration part. I will give the microphone to our colleague Niklas, and we will go to the questions and answer part.
Thank you very much, Daniel. Thank you very much, DDEC, for the excellent exposition of the case. So I hope this has been very interesting so far. We're now very interested to hearing your questions. So let's see. Here we have a question. Here we have a question from Giuseppe, who is asking, well, first of all, congratulating the good results, but he's also asking, how do you decide the actions to implement? Do you calculate the ROI on all of these? Are you comparing the data from DEXMA and doing analysis? Again, congrats. So that would be a question for Didac.
That's a very good question. In fact, now we are starting to calculate the ROE, but until now, the work has been mainly to expose the community of users to the data, and they immediately take actions that have not to do with investments, but have to do with management. So, for example, tell the cleaning service people to come a bit later in the morning, or ask the last one in each office to shut down the printer, or etc., etc. So every community somehow has a coordinator. Every building has a coordinator. He's supported by the head of the department or the unit or whatever, because sometimes there are tensions and conflicts, and he shouldn't be the one that deals with that. But this person, with a team of other people in the building, identifies any strategy to save energy. The last one is the investment. But there's a list of many things that can be done before that have not to do with investment. So you cannot calculate the ROI would be even infinite, because you spend €0 and you get any, and you divide, it's infinite. So, however, once you start doing savings, then you have some, let's say, thousands of euros to invest in your building. And where do you spend this? In the most efficient system, or in the most visible system? And this is not an obvious question, because your group of people, to keep saving, need some kind of positive feedback. And the positive feedback, if it is not visible, doesn't occur. Then you have to explain a lot of this. So if you do things that maybe they are not the most efficient, but are the most visible, or in between, you can get better results. And for example, it means that if you go to the bathroom after the first year of energy saving, and you see, oh, my efforts have been used to put some presence detectors that help me to be sure that when anybody is here, the light is off, that gives a positive feedback. So, but obviously, once you have done all these kind of basic efforts, then you can start with most relevant investments that have to do with analyzing the return of your investment. Okay?
Okay, so here we have another question from Carl from the UK, who is asking, so do you also work on improving the supply prices, or have you gained these results by only chasing the kilowatt hours?
Well, we have the energy results are independent of the energy prices. So this 20% we got, and 23 already now, it's about energy. But obviously, if we talk about sustainability, and we include also the economic dimension, the energy sustainability and working with optimizing your prices is fundamental. And the good news is that in the last 2 years, and working together with our neighboring universities, we got enough power to negotiate better tariffs and price of energy. So if you look in our data, you will see that the price that we paid last year, especially the one we are going to pay this year, we are paying this year already, is decreasing a bit. So that's a very good news, because we are not just only reducing the energy consumption, but also the energy bill because of that.
Great. Didac, here we have a question asking, and I think that it's really interesting. So how far can you arrive? So you are saving 25% right now. How far do you think you can arrive? You could arrive up to 50%, 60%, or that's impossible. Which is your opinion about that?
I would say that it's obvious there is an optimal somewhere, and should be around 30%. In some works that we did, some research work we did in the years before, we took during some doctoral thesis, we analyzed it deeply, the different elements or factors that influence the energy consumption of a building, and we saw that there was 1/3 you couldn't do anything. It depended on the building construction. 1/3 depended on the systems, and you need money to change it, but it's feasible. And 1/3 depends simply on the management and the use of people. And this 1/3, this last third, is the one we are attacking in this first phase, these first 4 years of energy plan. Obviously, it would be a bit stupid to keep trying to optimize something that is already optimized. But obviously, not all buildings are doing the job at the same time. Some are starting now, others started 3 years ago. So we have some kind of curve, of lapse curve, or that helps to you can pass the experience from ones to the others. So it's some work. You can replicate a lot of the learning in your community, and it's so we have work for so many years still ahead. Yes.
So we have another question here from Paul, who is asking, I would like to know if you monitor people comfort as well. For example, you say you can switch off the heating system later, so at 8 o'clock in the morning. Do you have any value on the comfort?
Comfort is a word that we don't use because comfort is so subjective that we would never agree on is it comfortable. Question. However, we perfectly understand that you could save all the energy by shutting down all the systems and getting people dying of frozen or boiled in your building. So that's not the idea. What we expect, and we are trying, is to, as a framework, not to alter and even improve the conditions, the environmental internal conditions of our buildings. And obviously, sometimes, because we are doing some kind of iterative approach, we go too further in looking for that optimization. So we think we need to remodify. Last July, an example. Last July, there was a decision from the manager of the university. Say, well, you only have 4 hours per day of cold air in your buildings. So it's up to you at every building to manage and to decide what time you will use that cooling systems on, and the rest, So it was a bit too hard because we got a terrible July in terms of temperature, and people were really boiling in there. So, well, obviously you will never have everybody happy, but it's not about stopping using energy simply to save energy, but it's to make the conditions even better than they are today.
So here are two questions that are a bit related. There's one where Jean-Marc is asking, could you tell us a word about the time and money needed to deploy Sirena? And I take it the whole solution with hardware and software and the time. And Jaume in Spain, who is asking, so it must have taken investment in equipment. So how did you actually get the initial investment approved? When you already have savings going, it's a different story. It's a different story.
Yes. In rough numbers, we have spent around 200,000 euros to set up our monitoring system. But this has been done during, let's say, 6, 7, 8 years. We started with the first version of Sirena. That was not with Dexma. It was our own made software around 2005. And from the very beginning, we started with some buildings that were monitored, and we identified the interest of putting this online and open. And so we have been building it. At the initial help came from the government, regional government, that gave us some grants. So we use it to install the first hardware. then after, today, what our growth, we have around 200 measuring points in all our campus, and we grow them or increase them with the savings. So it's some kind of retroalimentation system.
Yeah, somebody from Mexico here is asking us about the necessity of rewarding with that 25% in cost in each POE. Do you think it's a key fact? This so without that voluntary inside commas will be the same, or do you think that you won't engage that so much people?
It's absolutely fundamental. So I personally have been involved in energy saving in the last 15 years, and I perfectly noticed what I said before. Many people got interested by all that effort because we talked about this economic incentive, which at the end is not that much. And as I said, it's limited to new investments in energy savings. So you cannot spend it in books or in caterings for your staff. It really has to. So there are some conditions, framework conditions that make it quite tight, but it's fundamental simply to make your program a bit sexy, yeah, and simply people. What you have to avoid also is creating a bureaucratic system internally that make that at the end you are fighting for a dozen euros because my right is to get this. No. I just give you an example of last week. Because of new government shortcuts, our university has very little money to invest in new buildings, and the money that is invested in that 25% came from the budget of the next year. So in fact, it's not that we keep the money saved in a box and then we open the box and we give to people. It's simply that according to your reserves of the previous year, you have some opportunity to be better positioned in getting funds for the next year. Okay, that is key, because in the administration, unless you find these kind of solutions, it's impossible to transfer money from one place to the other. Well, there's not enough money to give to the community now, so we have reduced this incentive this year to 15%. That's a decision of this very week, in fact. And people have not complained, and that's very important, because we have created sense of community, of common good, where people understand that if there is not enough to give back, well, it's what it is. So I'm very happy and surprised at the same time that I thought that would be blamed by the half of the university, and it's not the case.
Okay, so we will have time for one or two questions more. Here is one that I think is a pretty direct question. Did you use IPMVP methods to calculate the energy savings?
Yeah, we are starting to use it, to get used to use it. So we are not extremely good in that yet, but exploring it.
And there's another question here. We have a partner that is specialist in public administration, corporate building, and he's asking about if do you think that he can replicate your model in their clients? So do you think that it would be useful outside of university sector?
Absolutely. In fact, our model is being used in some municipalities now and other organizations. The only relevant thing is this cannot be directed from the top. It has to come from bottom up. And to create that, you need a real community of practitioners that understand why they do that, and that they have self-motivators, so they are not simply mobilized by outside. So at the end, it's very difficult, I think, to create this from outside unless you identify some key people in the organization that can be those that help this network to get built.
So I think we're getting close to the hour, and I would like to just have one last, I wouldn't say question, I would just like to ask Didak that if you had to put all of this that we've heard today into one single phrase of what do you think is the magic formula to achieve these kind of results in energy efficiency, if you can find a single phrase, that we will let that end the session of today.
Well, it's not about technology, it's about people and communities.
So with that, I would like to thank Didac Ferrer, Daniel Uches, myself, Niklas Laura. We've been enchanted to have you with us today during this DEXMA webinar. We hope to, we wish you a great summer and hope to have you back with us for our upcoming webinar series for the autumn. Thank you very much and goodbye.